This illustration deals with the grounded service conductor. Now, before we get into this, let's look at the grounded loop neutral first. It has to be sized as a neutral, that grounded conductor coming in accordance with 220.61c. You determine if it's current carrying or not in accordance with 310.15 E1 through E3. In other words, the section 310.15 E1 through E3 tells you how to use the neutral, how to size it, and when is it considered current carrying. 310.14 A3 informational 2 is the golden rule for sizing that neutral. And it could be figured at 100% of continuous, non-continuous load, demand factors, or 125% for continuous load, plus the non-continuous loads and with demand factors. And we know that is outlined clearly for us in 220.61C as in car, informational note 2. Then 250.24C1 and C2 deals with the neutral, says it has to be routed with the phase conductors to where it connects to the service equipment. And then table 250.102C1 sizes that neutral conductor if it's to be used as an effective ground fault path and as a bonding jumper. In other words, it's being used as 3 conductors. Now for to make sure electricians understand this, the neutral in many cases will require a larger conductor for neutral load than it would be required for an effective ground fault path. Now section 15.9.9, along with chapter 7 and chapter 14 of 70B, instructs an electrician to review this information when they're working inside service equipment to make sure that that grounded conductor is large enough to serve as a neutral and an effective ground fault path, if that be the case. Now, 70B suggests check the circuit mapping, 408.4, the NEC. And if you have more neutral loads than you have phase-to-phase loads, then you know the neutral is going to be larger than what's required by table 250.102C1, 220.61 would be the section that would be used, because it would be used to calculate the neutral load. Now, for example, say that you calculated by 220.61 a number 4 neutral because you had more phase-to-phase loads. And the circuit mapping rule of 70B, as in boy, NFPA 70B, showed it's more phase-to-phase loads and very little neutral loads was number 4. But then when you reviewed table 250.102C1 based upon 4 conductors terminating to a 225 amp main, say on that panel board, you had to have a number 2. So it had to be number 2 and increased in size to serve as an effective ground fault path, serve as a neutral, and serve as a bonding means. Now, look at it this other way. Say that the neutral loads were dominant in the panel board, and you had to have a 1-aught along with a 4-aught for neutral load. Now the 1-aught is larger than what the number 2 would be per table 250.102C1, so you'd use the 1-aught. Now this is very important when you're using the grounded service conductor. Now we give you all those sections as you see in the illustration, dealing with the grounded conductor and the loop that we have listed for you. Now, how do we terminate with fittings? That's the next most important thing here. Then we could use pressure connectors, terminal bars. We could use pressure connectors listed as grounding and bonding, like 250.92B4 called out. Machine screw type fasteners, exothermic welding, the old CAD weld type connections. But if we use machine type 2 screws. Then notice we have not less than 2 threads that are secured with a nut. Very important there, so you'd have to check that out. And then a threaded forming machine type screws that engage not less than 2 threads in the enclosure, be okay. Connections that are of a listed assembly, and then other listed items in accordance with 110.3 B as in boy and C as in car, subject to approval of the authority having jurisdiction. Now that's what this figure 16-93 is illustrating, how the grounded service conductor can be used in accordance with NEC 250.92B1 and the sections that are used to size it as an effective ground path conductor as well as a neutral conductor, and then the type fittings that could be used to terminate it. That's what this figure is illustrating.